Hey gang, potentially a quick video here. What the final assignment you're going to have? This will be due. Let me go ahead and tell you. It's due by 2 p.m. Wednesday, December 16th. So in other words, it's due before you take your final exam. And again, final exam runs from 2 p.m. Oh, shoot. Let me write everything. 2 p.m. to 7 p.m. It's in Massey, room 108. And I'll be there from 2 o'clock to 7 o'clock. Guys, at 7 o'clock, I'm leaving. My daughter has a volleyball game, and I'm leaving at 7 so I can go watch her volleyball game. You got 5 hours to take your exam. Get there at 2. You mosey in at 6:45. You're going to have 15 minutes to take your exam. 5 hours that you can come in at any time and take your exam. Your our assignment number 4, which will be posted later today, will be due. I think it's 5 multiple choice questions, just like our assignment 1, 2, 3, the ones previous to that. So those of you that are doing these things, which is good because it's 100 points, you probably realize these are pretty easy points. Plus, you just get a lot of times you just get points just for kind of showing up, just turning them in. All right, gang. What I've got going here, I want to work this. This is a handout that I've uploaded to Blackboard, and it says something like data set for our assignment number 4. So I think this is what you'll see, data set for our assignment number 4. So if you like to have the document where you can write on it, I think it's better to do that instead of making this a passive activity. If you can actually work along with me, and I think it works better. All right, gang. What I want to do now is I want to go split screen on you. So let's go this way, and I want to bring up R. Oh, by the way, in case you care, there's a picture of me and my family. That's me. I'm the big ugly one on the left. There's Bailey. There's Sadie. There's my wife. All right, gang. Let's do this. All right. The very first thing, and this is going to be a good reason why it would be helpful if you have the document printed out, because it might be kind of small for you to see. Let me see if I can come in on this a little bit. Yeah, a little bit. All right, gang. The first thing we would need to do to work to examine the relationship between triceps and body fat is we need to get our data in now into R. Now it says the subject for this study are 10 women aged 25 to 34, and the purpose is to predict the woman's body fat from their skinned fold triceps measurement. Now, guys, this tells me, since I'm predicting this, that this is my Y, so I can go up here to body fat. This will be my Y, and since I'm predicting body fat from triceps, triceps will be my X. Now, I'm going to put this in R as something relevant. So I'm going to put in X, and I'm just going to call it triceps. And the way we've done before is just entered it with using what I call the C function. And this is the boring part where we have to type the stuff in without making a mistake. I need some AC/DC playing, don't I? People who haven't been watching videos regularly, they're like, where'd that come from? Well, should have paid attention. And 25.5. Okay. Now, the next thing that I'll do is enter body fat, and I'm just going to call it body fat. Nothing fancy there. All right, so I've got 11.9, 22.8, 18.7, 20.1, 12.9, 21.7, 27.1, where are we now? 25.4, 21.3, and 19.3. Okay, so guys, I've got triceps and body fat in, so now kind of comes the cool part. I'll just start using R to work the problems. Now, what I'm going to assume from here on out that this thing right here I'm pointing to, this document, that you either have it up on your computer or you've printed out a copy. So I'm going to just show the R screen from here to show you what I would do to work these problems. So anyway, the first problem says use R to find the descriptive statistics for each variable. And what I want to do first of all is look at the graphs, and I want to look at the distribution shape. So to find the histogram or the distribution shape, I would just do that, and you can see that we have a bell-shaped and symmetric distribution. You know what? I don't like this. I want both of those up. Sorry, I changed my mind midstream here. I want you to be able to see what I write as well as so the distribution shape for body fat is bell-shaped and symmetric, and then I want to get the distribution shape for triceps, so I'll do the same thing except for triceps. And again, I call that bell-shaped and symmetric at this level. All right, are there outliers? Well, to find outliers, we will look at a box plot. There's one outlier. It's designated by this small dot down here. All right, so outliers. There's one outlier, and then we'll do the same thing for triceps. And there are no outliers. Well, you can't see me writing that because I got up that, but again, no outliers. Now, what I want to do is look at the numerical summaries. Now, guys, we haven't even started the correlation, regression, residual analysis. All we're looking at now is just getting the basic descriptive statistics. Now we're going to look at the numerical summaries for body fat and triceps. So first thing I want to do is do the mean, and I want to do that for body fat. So it's 20.12. And then I want to do the mean for triceps. It's 25.63. Next thing I want to do is the median for body fat. It's 20.7. And I want to do the median for triceps. And I get 25.55. Guys, it doesn't get much easier than this. All right. Next thing I want to do is the standard deviation for each of these. So I get 4.83 and 4.41. And IQR, let's see, I think we have to do capitals on this, don't we? So IQR for body fat is 3.68. And IQR for triceps is 6.58. Now, the next question we see at the bottom, let me get this where you can see it, is use R to create a scatter plot and discuss the important characteristics. Is it linear or not linear, positive or negative, weak, moderate, or strong? So, guys, what I'm going to do over here, I'm going to make this a little larger. I'm just going to do a plot. And you always want your x to come first here. And we decided earlier that the x would be triceps and the y would be body fat. And we can see that we have a positive relationship. It appears sort of linear. It's a really small data set, so you're not getting a true linear pattern that emerges from this, but it doesn't have any curves. And I would say that the relationship looks to be kind of weak to moderate. So when I go back to this, I'm going to say that we have a linear relationship. I'm going to say we have a positive relationship, and I'm going to fudge a little bit here and say that we have a weak to moderate. Okay. Second page. Second page. Use R to calculate the following: the correlation coefficient and the coefficient of determination. Guys, the correlation coefficient is really easy. It's just COR between triceps and body fat. So the correlation is 0.71. And the coefficient of determination, which is R, is just that number squared. So what I can do, actually I can just hit the up arrow and then go the caret, as some people call it, the power button. And I see that I get 50.2%. All right, so remember, coefficient of determination, R squared, is typically presented as a percentage, where the correlation coefficient is something that is between -1 and +1. All right, but this one, the coefficient of determination, is typically presented as a percentage. Now, the next thing is use R to calculate the coefficients of the regression model. So we want the estimated slope. Guys, this is really easy too. It's just, I'm going to call it something. So I'm going to call it my model. And then I just use LM. And what I'll do first of all is I put in my Y, because my model is a function of Y. And then I use the tilde button. Now the tilde button, if you come all the way up to the top, well, not depending on your computer, but find your 1 key and look at the key to the left of your 1 key if your number keys are on the top. And well, on my computer it's right above the tab key. So anyway, you do your Y tilde X. And you might say, oh, I did something wrong, I didn't get anything. Well, you got to type model to see what you got. So guys, what we have here is the y-intercept is this number right here, 0.23, and the slope is given as your independent variable triceps. So again, this is your x. All right. So really easy. The estimated slope is 0.78. And the estimated y-intercept, let me move this over a little bit where you can see what I'm writing here. And the estimated y-intercept is 0.23. Now the next thing I ask you to do, I ask you to come in and state the model. And what you'd want to do here is you'd want to use the variables of the problem. So we would say that the body fat can be predicted by. Now guys, when we speak that language in regression, we use this notation. Remember, our linear regression model is used for prediction. It's not going to create an equation where the y value that you get have in your data set is going to be equal to the x times the slope plus the intercept. We're using this to predict, okay? So I'm going to do the slope first. That's 0.23. And I'm going to take that times the tricep measure. And then I'm going to add the 0.78. Okay? All right, easy stuff. Now, the next type of problem we've encountered in your textbook is the correlation coefficient R statistically significant? Well, probably the easiest way to do this is to use what's called a correlation t-test. So I'm going to do a correlation, well actually it's just a correlation test if I remember correctly, for my model. And then I want to do $ p-value. And that's not working. Oh, okay, I see what it is. To do this, we can't put in our model. We have to put in our X and our Y. So I have to put in triceps, comma, body fat. And p-value. Okay, well, that's interesting. All right, well, I was just trying to create it where we could just spit out the p-value, but for some reason it doesn't like that. So anyway, the Pearson correlation, which again, the correlation it gives you down here, 0.71, which we found out earlier. And I found out again right up here. But now we get a p-value for the correlation coefficient, and the p-value is found right there, and it's 0.02178. So the question over here is the correlation coefficient R statistically significant at the 0.05 level? Well, remember, statistical significance indicates that your p-value is less than your alpha. So our p-value in this problem is 0.02, and our alpha was 0.05. So yes, our correlation coefficient is statistically significant. Okay? Because our p-value, which we get from R, is less than the 0.05 level that we're actually testing our statistical significance at. All right, cool. Now, the last thing, use R to calculate the residuals. Guys, I'll tell you what, this is really simple to do. I love the way R does residuals. Now, all you have to do here is just go RESID. I'll tell you what, I want to save these things. So let's save them as residuals. And then let's calculate them. So the command in R to calculate the residuals is RESID, and what I'm doing is I'm storing those under the heading of residual. Okay, and all I have to do is just do RESID of my model, because way back here I called my model, the linear model that examines the relationship between triceps and body fat. I called it model. So now all I have to do is calculate the residuals for my model. All right. Now, when I want to see them, I can see them right there. Now, the question number 6 says, use R to calculate the residuals, which we did. Report and interpret the residual for subject number 1. Well, subject number 1's residual is right under 1. That's kind of just the way it works. So the residual for subject number 1 is minus 3.46. Now, what does this tell us? What this tells us is the observed Y, which in this case is body fat, for this subject, and all these subjects are women, so I can say the observed Y, the body fat for this woman, is 3.46 less than what is predicted by her tricep skin fold measure. So the uh, the body fat that we would have predicted for this woman uh, is actually higher than what we actually observed. Now, a good way to look at that on R, in fact, a really cool way to look at that on R, let me get this to work appropriately, is just to go ahead and create the predicted values. So what I can do there is I can create what's called fitted. So I'm just going to call this the, I'm going to call this the predicted. And I can use fitted for the model, and then I can create the predicted values. Now, now remember, I can look at the body fat, and I can look at the values. So the first measurement I see for the observed body fat is 11.9. So that's the observed body fat for the first subject. Her predicted body fat was 15.36187. Hence the minus 3.46187 that we got up here as the residual. So again, the residual is just the difference in what we observed, the 11.9, and what we predicted, the 15.3687. Guys, there's going to be an assignment, or I'm sorry, an exam question that's going to give you a model, and you're going to have the observed X, the observed Y, and you're going to use your model to predict the Y, and then ultimately calculate the residual. Guys, that's all I got. The next thing that I'll do is post your assignment. It will be 5 multiple choice questions. So good luck. That's all I got. Take care.